So now we've taken a look at a shortcut in how to graph quadratics. For example, let's say I have the quadratic function f of x equals 2 times x minus 3 squared plus 4. Well, I should look at that equation and I should determine right away that I know the vertex. And I know the vertex of that equation because it's in vertex form. So looking very carefully, it's the number inside parentheses, number outside parentheses. Remember that you take the opposite sign of the number inside parentheses. So now all I need to do is make a table of 5 values, remembering that my vertex should be my center point of my table. So I need to choose 2 values around the vertex, 2 x's that are smaller and 2 x's that are bigger. And it would really be wise of me to choose consecutive values that are all integers. So 1, 2, 3, 4, 5. Now, to find the y's, I'm going to take at least 2 of these x's and plug them into the original equation. So 2 times 2 minus 3 squared plus 4. Order of operations, 2 times negative 1 squared plus 4. That's 2 times 1, which gives me 6. So I'm going to fill in a 6 there. Let's do the same thing now with the 1. 2 times 1 minus 3 squared plus 4. That's 2 times negative 2 squared plus 4. It's 2 times 4 plus 4, which is 8 plus 4, which is 12. Now, because it's a parabola, and because the sides are symmetric to each other, and also because 3 is right in between 2 and 4, I know that 4 will have a y value of 6 and 5 will have a y value of 12 without even having to plug in any work. Similarly, I could use the same method if I have an equation that's not in vertex form. So now I have an equation that's in standard form. So I'm going to start by finding my vertex. But in this case, I can't just take the vertex from the equation. I need to remember my small equation, negative b over 2a. Well, a is 2, b is also 2, and c is negative 1. So that's going to give me negative 2 over 2 times 2, which is going to give me negative 1/2. So again, setting up my table, vertex goes at the center. Now, I'm going to pick 2 values around it. Well, negative 1 is the next integer right below it, negative 2. Above it would be 0 and 1. So notice that even though my vertex is a decimal, I'm choosing integers around it, because integers are just going to be so much easier to graph. Now, how do I fill in my y's? Well, in this case, I'm going to have to plug in the vertex into my original equation. So 2 times negative 1/2 squared plus 2 times negative 1/2 minus 1, which is going to give me 2 times 1/4 plus 2 times negative 1/2 minus 1, which is going to give me 0.5 minus 1 minus 1 is going to give me negative 1.5. Now trying to plug in the negative 1, so 2 times negative 1 squared plus 2 times negative 1 minus 1, that's 2 times 1 plus 2 times negative 1 minus 1. 2 minus 2 minus 1 gives me negative 1 there. Try to plug in negative 2. 2 times negative 2 squared plus 2 times negative 2 minus 1. 2 times 4 minus 4 minus 1. 8 minus 4 minus 1 gives me 3. And on the other side, negative 1 and 3 are also correct. So we would graph that table. Now, sometimes we have an equation that looks a bit different. Sometimes we might have an equation that looks something like this. 4x squared plus 1. Is that in vertex form or in standard form? Well, the easiest thing to do would be to decide, okay, let's make it in standard form. So A is 4 and C is 1. There is no middle term. There is no middle term. So what must B be? Well, since there is no middle term, B must be 0, so that this equation is actually 4x squared plus 0x plus 1. So to find my vertex, I'm going to take negative b over 2a, which in this case would be negative 0 over 8, which is just 0. So again, x, y,
Good morning,
0, negative 1, negative 2, 1 and 2.
And get your breakfast.
So I'll plug in 0, so 4 times 0 squared plus 1 gives me 1. I'll plug in 1, 4 times 1 squared plus 1 gives me 5. Now I'll plug in 2, 4 times 2 squared plus 1, that's 4 times 4 plus 1, 17. Same thing on the other side. So that's my shortcut to graphing parabolas.